Okay, so we're going to talk about Taylor expansions to approximate. Now, on your Khan Academy, it might say the word Maclaurin, and that just means that C equals 0. Okay, and you'll know what I mean by that in a minute. Okay, so the goal is to find a polynomial oh, excuse me, P of x that approximates f of x near center C. All right, and here's how you do it. Pn of C equals f of C, as you saw the explanation of in that Khan Academy video. Hopefully you watched it. Plus f prime of C times x minus C plus f double prime of C over 2 times x minus C squared plus f triple prime of C over 3 factorial. And this is 2 factorial, right? But which is 2. And this one's 1 factorial. Okay. X minus C cubed. And then here is the part that we really care about. It's just this formula over and over again. All right, let's do an example. For f of x equals e to the x, find a 3rd degree Maclaurin polynomial approximation, or polynomial, period. Use it to approximate e to the 0.01. All right, so we're just going to use that formula right here. All right, so we got to find, so it says 3rd degree. Maclaurin just means C equals 0, which is good because 0.01 is close to 0, so it has to be an approximation when you plug it in to x that's close to the center. Okay? All right. Okay. All right. So, hang on a second, I have to go get a charger cord. Sorry for me. Very professional recording here. Let's see, Lovey. Okay. Okay. So let's do it. So we need f of 0, right? Which is e to the 0, which is 1. F prime of 0, f double prime of 0, and f triple prime of 0. Well, what's the derivative? What's f prime of x? And then the second derivative and third, they're all e to the x. So these all are just 1. That's nice. Okay, so P3 of x is 1 plus 1 times x minus 0, right, to the first, plus 1 over 2 factorial x minus 0 to the second, plus 1 over 3 factorial x minus 0 to the third. So P3 of x is 1 plus x plus 1/2 x squared plus 1/6 x cubed. Bless you. All right. And then we approximate, so then that means that e to the 0.01 is approximately P3 of 0.01, which is equal to, that side's equal to it. This is approximately 1 plus 0.01 plus 1/2 times 0.01 squared plus 1/6 times 0.01 cubed. Now let's actually find them in our calculator. Let's graph them. Okay, first I'm going to graph e to the x. And then now I'm going to graph my third degree polynomial. So 1 plus x plus 1/2 x squared plus 1/6 x third. Sorry, I'm so shaky. I was painting. Woo, look at that. That is pretty awesome. Okay, now I'm going to just evaluate. I'm going to do 0.01. And for E, I get 1.01000502. And look at that. Man, that's pretty amazing. And that's only third degree. That was not that hard. Okay. All right. Let's do another one. I think I'll turn the page. Find P4 of x for f of x equals the square root of x at x equals 1. Okay. All right, so we're going to need f of x is x to the 1/2, f prime of x, we're going to need to go to 4, is 1/2 x to the negative 1/2, f double prime is what? Sorry, I'm trying to hold this the right way so you can see it. Okay, there we go. Bring it down, so that'd be negative 1/4 x to the what? 1/2 minus 1, so negative 3/2. And then f triple prime of x is going to be 3/8 x to the negative 5/2. Yeah, 3 minus 2. And then f4 of x is negative 15/16 x to the negative 7/2. Okay, and then what we would have done in the future is like find a pattern for this and write a series and then find its convergence and all that. But you guys lucked out, or not. I don't know. I guess not really, but at least on the exam you did. All right. So let's see. Now we're going to evaluate each one of these at 0. I'm just going to put big old bar. I don't know if that's okay or not. No, not at 0, at 1. And I get 1, 1/2, negative 1/4, 3/8, negative 15/16. Okay, and then now I'm going to use those to write my P4. 1 plus 1/2 over 1, right? X minus 1 to the first. Plus negative 1/4 over 2 factorial x minus 1 squared. Plus 3/8 over 3 factorial x minus 1 cubed. Plus negative 15/16 over 4 factorial x minus 1 to the 4th. And that's it. Okay. Let's graph them. I mean, but you can just box that answer. That you do not have to make it pretty or any of that. This is the approximation. Okay. Let's graph them both and see. Okay, so we get, so the first one is the square root of x. And I don't know why anybody would want to do this for an approximation at 1. I mean, I guess you could do like, and then plug in 1.2 or something, or 1.113, and that would be pretty difficult to approximate, but I would just say it's about 1. Okay, but anyway, I guess you might need better approximations than that. It depends on your error, like how much error you want in something, which means like how close you're okay with being. X minus 1 minus 1/4 over 2 times x minus 1 squared plus 3/8 over 6 times x minus 1 cubed minus 15/16 over 4 times, oh, I can do that in my head, right? So that would be 24 times x minus 1 to the 4th. Now it should be good at 1 if we did it correctly. Doesn't matter about at 0. Yeah, buddy. Look at that. That's pretty good. All the way up to about 2, it's good. So I could approximate it at 1.8 and it'd probably be okay. Pretty good approximation. Let's try. Let's do value at like 1.7 or 1.8. Let's do 1.8. I mean, they look like they line up for a while there, yeah. Okay. That one. 1.336, 1.34. Okay. 1.303. There we go. Okay. Yeah. See? All right. That's it.